we will see in this lecture numerical on strain energy and impact. Numerical is a load of 50 Newton falls by gravity through a vertical distance of 2000 mm when it is suddenly stopped by a collar at the end of a vertical rod of length 6 meter and diameter 20 mm. Calculate the maximum stress and strain induced in the bar. The top of the bar is rigidly to the ceiling. Assume modulus of elasticity as 1.96 into 10 raised to 5 Newton per mm square. So, we will see first given data in this numerical. In red color, see, they have given us this. First, see this impact load arrangement. This is member. This red color mark here. This is member, and this member is at top. It is rigidly fixed to the ceiling. See here. This is rigidly fixed to the ceiling, and at bottom it is also rigidly fixed to the collar, and this is collar, and this is movable load. When this movable load impact on this collar, this bottom one is collar, due to this impact load, this bottom change its shape, slightly change its shape, and this change its shape is delta L, and this member total length is this L, and this is dropping height h, small h. And in this numerical they have given us this L is 2000 mm, this movable load W is 50 Newton, this member is of dia 20 mm, and here this is 2000, this h is 2000. See here, 50 Newton falls by a gravity through a vertical distance of 2000 mm. That means this is 2000 mm, and this L is always greater than or equal to 2000 mm. So 2000, no, this h. See, this h is smaller and this L is greater because this L is member length. So this L is here 6 meter. That means 6000 mm. And they also tells us that modulus of elasticity is 1.96 into 10 raised to 5, and our problem statement is to calculate maximum stress and strain. That means this sigma max and strain E. And strain E is nothing but change in length upon original length. So we will see this numerical, how to solve these. First, write our sigma max formula. Sigma max for impact load is load upon area plus under root of load upon area square plus 2 into modulus of elasticity into EH into height, and again W term comes here, to EHW upon volume area into length. So W is this 15 Newton. So 15 Newton as it is. We put in this formula values are Newton and mm. So 15 Newton as it is. Area, the area is the member of that member area, vertical member area. They have given us dia, so area is dia they given. That means we know that this is circular, and circular area is pi by 4 into d square. Pi by 4 into 20 square is 314.16 mm square. This is the area. 6 plus under root of Again this term square, 50 upon 314.16 square, 2 into E is 1.96 into 10 raised to 5 Newton per mm square. H is this 2000 mm. And W is again 50 and divided by area is 314.16 multiplied by length is this 6000 mm. So this sigma max is 50 upon 314.314.16 is 0.159 plus under root of 0.159 square 0.0252 plus 2 into 1.96 into 10 raised to 5 into 2000 into 50 upon 314.16 into 6000. So this value is 20.796 into 10 raised to 3. So this sigma max is equal to 0.0252 plus 20.796 into 10 raised to 3 and square root of this term plus 0.159. That means this sigma max is 144.367 Newton per mm square. So our first problem statement is complete. We find this sigma max. Now next is strain induced in the bar. So they don't give us change in length also. We have only L in this formula, strain formula. Our stress is also, so we will see this stress. Our modulus of elasticity is stress upon strain. E is equal to stress upon delta L upon L. E into delta L upon L is equal to stress, and delta L is equal to sigma L upon E. So see, we have sigma, we have L, and we have E. So use this formula. Delta L is equal to sigma L upon E. Second. So, but see, we don't find this delta L here also. Our problem statement is to find E. E is change in length upon L. So from this formula we will find delta L. We have L also. Now from this we get delta L. So this is methodology. First use this formula for calculation of change in length, then use this change in length upon original. For E, strain. Sigma L upon E. Sigma is this 144.367. Length is, use that maximum length, member length 6000 mm. And E is 1.96 into 10 raised to 5. So 144.367 into 6000 divided by 1.96 into 10 raised to 5 is 4.42 mm. Cross check this unit. See, this stress is in Newton per mm square, this length is in mm upon This E is in Newton per mm square. So this Newton per mm square, this Newton per remaining mm. So this is mm is right. And E strain. Strain is not E is nothing but change in length upon original length. Change in length is 4.42 and L is this 6000 mm. So 4.42 divided by 6000 is 7.36 into 10 raised to minus 4 mm. No mm, no, strain is unitless quantity. So by that way, we had solved this numerical. We had only we had data, movable load, weight, member dia, height from which movable load drops, impact on this collar, and length of that member. So from this data, by using this impact load stress formula and delta L formula and strain formula, we had solved this numerical by that way. Thank you very much.